So these problems are nice and quick. And because they're quick, the AP writers often look to put in little tricks. And that's what we see with examples 3 and 4. Notice the upper bound with example 3. It's not just x like it was with the first two examples. Okay, so in this case, the first question that students wonder is, well, can I just plug in the x to the fourth like I plugged in the x in the previous problems? And the answer to that question is yes, you can still do that, okay? But there's something more that needs to be done. So once again, I'm going to do it out the long way. It's going to take a little bit longer this time. And after I've done it out the long way, then we can figure out what the actual shortcut is, okay? So we know that we have to antiderive, and then we plug in x to the fourth and 0. Nice that we got to plug in 0 because that's going to be nice and quick. Let's get our antiderivative first. So we know that we have, t cubed is going to become t to the fourth over 4. T is going to become t squared over 2 minus 2t. That's being evaluated from 0 to x to the fourth, and we are still taking the derivative of everything. All right, so we're keeping that derivative out front until the very end. Now we're going to plug in x to the fourth first and then 0 second. So when we plug in x to the fourth, we have x to the fourth over 4, and then we have x to the fourth squared over 2 minus 2x to the fourth. That's what happens when we plug in x to the fourth. When we plug in 0, we get 0 plus 0 minus 0. So there's nothing there. I'm not even going to bother to write it, okay? But I do need to continue to write the fact that we're deriving this, all right? Because we know what's going to happen. Somehow the derivative is going to cancel everything out. What happens when we derive this term? All right, well, again, we're using our basic derivative rules. Maybe we should just rewrite this a little bit first. So we have the derivative of x to the 16th. 4 to the fourth is 16 there, over 4, plus x to the 8th over 2 minus 2x to the fourth. So when we derive this, this becomes 16x to the 15th, and we're still over 4. And this becomes 8x to the 7th over 2, and this becomes 8x cubed. All right, so this doesn't look like that, except with x to the fourth where there's a t, or does it? All right, well, let's take a look here. Let's simplify this a touch. So do I still have some room? I can sneak it in down here. So we see here that 16 divided by 4, that's really 4x to the 15th. And this is going to be 4x to the 7th, and that's going to be still 8x cubed. All right, so how can we get this to kind of look like that? Well, keep in mind that our original thought was, can we just plug in x to the fourth? Now, if we plug in x to the fourth, we have x to the fourth cubed. What would that be? X to the fourth being cubed. Yeah, we're going to multiply the exponents. That's x to the 12th. All right, so we know we're thinking x to the 12th. All right, now we plug in x to the fourth here, so that's plus x to the fourth, and then we see a minus 2. Okay, well, how does this relate to that? All right, how can we just plug in x to the fourth? Well, obviously we have to do more. What do these three terms have in common? All right, what's their common factor? We see 4, 4, and 8. So they have a common factor of 4. All right, so we can make this, I'm going to put it right up here, 4. And then what else can they have in common? They have x to the 15th, x to the 7th, and x cubed. What do they have in common? X to the 3rd. So let's factor out a 4x to the 3rd. So we have 4x to the 15th divided by 4x to the 3rd. That means we subtract the exponents and we divide the coefficients. So 4 divided by 4 is 1. 15 minus 3 is 12. Oh, here we go. All right. Now, 4x to the 7th, well, we're going to factor out a 4x cubed. That leaves us with x to the 4th. And then finally, 8x cubed divided by 4x cubed, that's just 2. So notice we do have our x to the 12th plus x to the 4th minus 2, but we also have this 4x cubed out front. Where did that 4x cubed come from? If you're thinking, you realize that 4x cubed is the derivative of x to the 4th, and that's correct. All right, so can we just plug in the x to the 4th? Yes, we can. Right, and we can put it in here, and we get our x to the 12th and x to the 4th after we simplify. Okay, so yes, you can plug this in, but you also have to multiply by the derivative of that inner function. So why do we have to do that? Well, we're deriving. We're deriving and we have an inner function. What rule did we have to use when we were deriving with the inner function? Exactly, it was the chain rule, all right? And the chain rule said derive the outer, keep the inner, and then multiply by the derivative of the inner. That's what we're doing right here. Deriving the outer is with the derivative in the integral going away. Keeping the inner is plugging the x to the fourth in, hence the reason why we have them right here. But then what was our third step? Multiply by the derivative of the inner function. And the inner function is x to the fourth, so we multiply by the derivative of that, we get 4x cubed. So this is our answer right here. And again, you can get it very quickly by just plugging in the upper bound, all right, plugging in the x to the fourth here and here, which produces those two things, but then you have to multiply by the derivative of the upper bound. Okay, if you don't do that, you end up with just this term. And trust me, if this is a multiple choice question, that's going to be option A. They're going to check and see, did you remember to multiply by the derivative of the inner function? And if you do, then you'll pick this one, which will be B or C. And if you don't, then you're going to pick that one, and unfortunately, you won't earn the point. All right. So now that we know that, let's do number 4 really quick. All right. Number 4 actually has 2 tricks to it. We see the 3x, so we know that we have the inner function. It's not as bad as x to the fourth, but it's still more than just x. We have that inner function, but we also see that it's in the lower bound. Right? We don't want it in the lower bound, right? We want it in the upper bound. Okay, so we have to swap the bounds. Now, what's the cost of swapping the bounds, which we're allowed to do? Yeah, it's to negate. So we can make the 3x up here and the 2 down there, but we need that negative sign right there. We're swapping the bounds, so we have to negate it because we want to go in the other direction. Okay, so what do? We replace t with 3x. All right, so we have sine 3x, and then we have 4 times 3x minus 9 in the denominator. Okay, so we're replacing the t with the inner function. Okay. We still need our negative sign because that didn't go away. That's a coefficient, so that stays. All right? And then we need to multiply this by the derivative of the inner function. What's the derivative of 3x? Yeah, it's just 3. So we have negative 3 times the sign, and you can do parentheses around that if you want to. You don't have to because it's a fraction. We know that the negative 3 actually applies to the numerator. And you can make that denominator 12x minus 9 if you want to. Again, not important at this point. The key is that you realize that you get to plug in the function, but you must also multiply by the derivative of that inner function.